Hi guys, this is Chapter 4, Equations of Linear Functions, Lesson 4.3, Writing Equations in Point-Slope Form. I'm in the textbook on page 233, and if you follow along, there's lots of good examples that you can read through on your own, and I'll walk you through the gist and then work some problems for you. When you're done, there'll be a practice assignment in Alex for you to do, and I will also post a help video working those problems, and I'll post that on the assignment in Google Classroom. So let's talk about point slope form, or rather let's review what you've seen before point slope form. So up until now we've kind of seen this form a little bit. This is called standard form. Really, this form, in my opinion, is not super useful. The A and the B don't really tell us any definite, specific information. And so if we want to use this form of the equation and graph it, we really need to do something like find the x-intercept and the y-intercept, which we can do by plugging in 0 for x, getting the y-intercept, or plugging in 0 for y, getting the x-intercept. That is useful, but sometimes people, when they see this form, go ahead and use some algebra to rearrange it into this form. This seems to be everybody's favorite form. We have talked about this over the last couple of lessons. This is called slope-intercept form. It's called slope-intercept form, literally, because you can see the slope, which is the m in the equation, and you can see the intercept. It happens to be the y-intercept, and that is the b in the equation. And so that's why we call it slope-intercept form. This is really useful, but today I want to show you something called point-slope form, and it goes something like this. Y minus y1 equals m times x minus x1. And this is called the point slope form. Let me remind you right now that you should be taking notes. Please write all this stuff down so that it's right there in front of you and you can look back at it. The reason we're going to call this point slope form is there is a point involved in this equation, an x1 and a y1. Those are just denoting that we're picking some x and y that go together. Here is the x1, and notice that the minus is just part of the equation. It's not the number that the x is. The x isn't necessarily negative. In fact, it's probably not if you have a minus there. And there's your y1. So we have a point. Let's say it's like the point 2 and 3 or something like that. And those numbers will appear here in this equation. The x and the y are the variables that are there no matter what. Okay, the other thing we can see is slope, and slope is m. It's the same slope that we've been looking at, and it will be the same number no matter how you work it around. So if you were to see it in slope-intercept form or in point-slope form, that m number would be the slope. Can we take this form and rework it into slope-intercept form? Yes, we can. So let's talk about that, but we'll also talk about why we would use the point-slope form. It's particularly handy if you have a problem like, jump to page 235 and look at number 1. And let's say someone asks us to write an equation in point-slope form for a line that passes through the given point with the given slope. I would write the equation in point-slope form, even if they didn't ask me to do that. If I was trying to find even slope-intercept form, I would start here. In the last lesson, we plugged in an x and a y and solved for b, but this is a better way, in my opinion, to do that same problem. So in this problem, we have -2 and 5 as a point. That's our x1, y1. And we know that our slope is -6. So we're going to fill this equation in. We're going to say y minus 5 equals x, whoops, I forgot the m, which is -6 times x minus a -2. So I want you to notice that I plugged in that -2 and I plugged in the minus. So what we're going to end up with here is plus plus. So if I rewrite this, I could say y minus 5 equals -6 times x plus 2. And notice if I have plus 2, it means that I had minus minus. I had minus and negative. And so that's going to be true when you see the plus. Okay, I usually am asked to go ahead and write this in another form, like slope-intercept form. But in this case, the problem just asked me to stop right there. So I'm going to look at number 2. And it asks me the same question with some different numbers. So I have a point, -2 and -8. That's my x1, y1. And I have a slope of 5, 6. And I'm going to write the equation y minus a -8. Be careful, you kind of want to write the x number there, but it's not. You want to stay with the y number. Y is usually on the left here. Y minus a -8 equals m, don't forget your m, happens to be 5, 6, times x minus a -2. I doubt that Alex is going to let you write them like that, so let's know that when we have minus minus, it just becomes plus. And I have y plus 8 equals 5, 6 times x plus 2. Now, if you didn't take notes earlier and now you're wondering what that formula is, go back here. Y minus y1 equals m times x minus x1 is point slope form. If you didn't write that down before, you need to have that written down now. All right, I'm going to jump to number 4. It says write each equation in standard form. Okay, so now I'm given an equation in point slope form, because remember, I can see a point. In this case, the point is 3 and -2. See, because it's plus 2, that means it had to be minus a -2. This is the point that I can see in the point slope form, and I can see the slope, which happens to be 7/8. That's why that's called that. But we're going to rearrange this into standard form. So I'm going to start by kind of undoing the parentheses. I'm going to use the distributive property. And I'm going to get y plus 2 equals 7/8 x minus, I'm going to wish I had my calculator with me, 21/8. I'll see how this goes. And then I need to subtract 2. Oh, no, wait. I started to go to slope-intercept form, which is really common, but I'm going to standard form. So standard form is this, ax plus by plus c, or equals c. I'm not sure what's going on with me. There we go. So in this case, I need this to go to the other side. And so I'm going to subtract it. Remember, sometimes we use these techniques, not because we're solving anything, but just because we're rearranging. So I have -7/8 x plus y plus 2 equals -21/8. That looks pretty messy, doesn't it? But it'll start to clean up if we get our 2 moved to the other side. So I have -7/8 x plus y equals, and in this case I need to do this math. This would be minus 16/8. You're welcome to use your calculator, guys. I just didn't happen to pick it up before I started this. This becomes plus a negative, so I'm actually combining here. 37/8. That's kind of yucky. So I need to show you one more thing about the standard form. The standard form has two kind of picky rules. One is no fractions, and the other is no starting negatives. So the starting negative in this case is this. If I were to multiply this entire thing times, say, a -1, it would just change things around a bit to look like this. 7/8 x minus y equals -37/8. So see how everything just changed signs? The only reason I did that is because it is standard to not start with a negative, to start with a positive, and then let everything else adjust to that. Okay, the next thing I want to take care of is the fact that there's no fractions. So I'm going to multiply all of this times 8. The denominator 8 is going to cancel out all those fractions and clean it up a lot. So I'm going to have 7x minus 8y. Take note that I had to multiply this by 8 also. Sometimes we forget that. And this will equal a -37. This is not so bad now. This is the actual equation I was looking for. In the answer key, I can see that it's supposed to be a +37, so I must have made a little math error somewhere here. And let's see if I can see it. Maybe you see it already, which would be awesome. When I'm subtracting 2, it's funny. Oh, I think I see that what I did wrong now. Here, I'll show you in another color so it sticks out. So when I did this math right here, this was supposed to be negative, and so therefore this became a positive, and it would be a positive here. So my real answer is this: 7x minus 8y equals 37. So how's that?